Come on. Okay, this doesn't work either. Right, my name's Pete Finnigan. I specialise in Oracle security and researching internals and security of Oracle databases. This talks about the wrapping mechanism used to hide PLSQL source code. I've been interested in this for quite some time, and my interest was made even stronger when I found this book on the internet, which I bought in 2003, which will become apparent why in a minute. I wanted to investigate why the method chosen by Oracle to secure source code is weak in PLSQL. I also felt that it was intriguing that Oracle had made it easy in quotes, because it's not that easy really, to unwrap PLSQL, basically because they provide interfaces to the APIs used. I'll move on to the next slide. So the agenda, we're just going to look at a simple procedure. We're going to look at how it gets wrapped, where it's stored, the tables and views used, and various events and dump commands and so on to get data out of the database to see the internals of this. We're going to look at why it's possible to read wrapped code, and this has been driven by history and a design choice by Oracle in the way that PLSQL has been implemented. We're also going to look at how it's possible to read wrap code. That's primarily because of the APIs that Oracle have shipped. We're going to look at 10G briefly, and also a slide on some ideas on how you might protect your PLSQL source code. So what's the problem with wrapped PLSQL? The first half of this talk is going to concentrate on 9i, but some of these issues are valid for both versions. The wrapping mechanism changed in 10G. I don't know if anyone's aware of that. Some of the reasons why is because if you use the wrapping mechanism to hide your intellectual property, your algorithms, the way you've written your code, stuff you don't want your competitors to steal, if somebody can unwrap it, then they can steal those algorithms and work out how you've done something. So this could be your own application source code. It can also be critical data that's held in the source code. Obviously, Oracle ship a lot of the built-in packages that are wrapped with their own wrapper as well. In 9i and lower, which we'll look at in a second, I've got a slide on this, the wrapping mechanism also revealed information in the wrap file, particularly the symbol table. Of course, if you can unwrap PLSQL, then finding SQL injection bugs is also a lot easier, because you can just use tools like grep and search on Windows to look for particular vulnerable strings, concatenations and so on. There are PLSQL unwrapping tools available if you know where to look and who to ask to get them. They've been available probably since about 2003, and I know of 5 different ones at the moment. So the PLSQL language. So you got PLSQL source code, you got a PLSQL compiler front end. That compiles the PLSQL into an intermediate language called Diana, distributed, I think, I can't remember the name of it. We'll come back to that in a minute. It's an intermediate language. That is then parsed by the back end of the compiler to generate machine code. In this case, it's called M code in PLSQL. So Diana is the key for 9i and lower. PLSQL is based on Ada, so a lot of the design choices were because of Ada. The Diana is a descriptive intermediate attributed notation for Ada. This is actually an abstract data type, which means that it stores values and provides operations on those values. As we just said, it's an intermediate form of the PLSQL programs. That's not just for compiler. In the Ada world, it was also used for pretty printers and source code editors, syntax highlighted editors and so on. It is primarily intended to communicate between the front end and the back end of a PLSQL compiler. An interesting point is that each defining Diana entity represents a PLSQL entity. That's not just a particular node, it may be a set of nodes. Diana is built in trees. That's a logical construct. If it's actually implemented in trees, then that's just a coincidence. It doesn't have to be implemented as a tree, for instance, in a C code construct. The abstract syntax tree, there are actually two trees that are generated in Diana. An abstract syntax tree, which is constructed prior to the semantic analysis. That's just basically the structure, and that should map almost directly to the Ada formal definition when it was based on Ada. I guess it primarily does almost the same thing with PLSQL. It then becomes an attributed tree, so that each node in the tree also has attributes. We'll look at the attributes shortly. This is the Diana structure. I don't think my zipper thing works. There's also another language that comes into play, interface description language. Sometimes it's called interface definition language. Diana is written down as IDL. It's basically the language that's used at interfaces. This can either be an external interface or an internal interface. In the case of the database, there are 4 tables that you can find in the sys schema: sys.idl char$, sys.idl sb4$, and the other 2 that are listed there. Those store information about PLSQL. They store the symbol table, they store the Diana, and they store the machine code. The method that they're written down, that's called IDL, hence they're called IDL tables. So that's just an interpretation of the Diana that's written down to disk in a table. Wrapped PLSQL, if you hadn't already guessed, is just Diana that's written down in a different form when it's written out to an operating system file. Because if you look at a wrapped file, it's not the same format as what's in the IDL dollar tables, although the same information is actually there. So as we've said, is wrapped PLSQL therefore Diana reversible? Yes, it is. This book that I just held up, quite interestingly, has got an appendix called Reconstructing the Source, page 165. I'll just read these out. One of the basic principles of Diana is that the structure of the original source program is to be retained in the Diana representation. That's because in Ada, the abstract syntax tree mapped almost directly to the Ada formal description. There are some slight differences. So therefore, there's a close correspondence between Ada's syntax and Diana's structural attributes. Because PLSQL is based on Ada and the core language features are probably almost the same, then I guess that's still valid for PLSQL. And it's this correspondence that permits the source code reconstruction. And from Oracle's own documentation, so Oracle now confirms that PLSQL is based on Ada. As a result, PLSQL uses a variant of Diana, a tree-structured language. It's defined using a meta-notation called IDL. Diana is used internally by compilers and other tools. So at compile time, PLSQL is translated into M code, and both the Diana and M code are stored in the database. That's not strictly true because the Diana is only stored in the database for procedures and functions and some other small bits of PLSQL. For instance, package bodies are not, the Diana is not stored in the database. So just create a simple procedure, about as simple as you can get. It's got no parameters, it's got no local variables, and it's just got a null statement for the main block. So you just go in SQL+ and create this. We can then save it, and then we can use the wrap mechanism to convert that to a wrapped file. So the wrap program is quite simple. You just give it an iname parameter and an oname parameter, and what it does is write the wrapped output to aa.pls in this case. And that's actually wrapped PLSQL, which, as we've already guessed, is Diana. I've got an example of a complete file here. This one shows it a bit better because it's the complete file, which is a bit harder to show in a slide. I don't know what this ABCD bit is at the top. Things that pop out immediately is the 920. This is from a 9.2 database, so that's clearly the version. Another obvious thing is the symbol table, because the only symbol in the program is AB, the name of the procedure. And pay particular attention to this list of hexadecimal values. We're going to see them again in a minute. So just taking a slight detour as to why 9i and below wrapped PLSQL has weaknesses. I've just created a simple procedure here that has no body in it, but that's intentional. It's just for a demonstration to show why there's a weakness. So this procedure called encode might be used to encrypt credit cards. And in there we've got a variable called key, and we're giving it a value not 1, 2, 3 up to F. And that in a real procedure would be passed as the key to an encryption function, and you'd encrypt the credit cards with it. If we wrap that using the same mechanism that we've just seen in the previous slide, and then actually look at the wrapped file, you can read the symbol table and you can see the word key, you can see 16, we can see varchar 2, and we can see the value. It doesn't take a lot of reasoning to understand that that's a key used in an encryption. I've actually got some of this written down in the next slide. So you deduce the purpose of the procedure. In this case, it was easy to deduce because it's called encode. It had a parameter called credit card. You could find out the encryption algorithm used inside the procedure if it was an external encryption algorithm using the DBA dependencies view. So for instance, if DBMS obfuscation toolkit had been used to do the encryption, then that would be, you'd be able to find that from the DBA dependencies view. And in this case, because we've got the key and DBMS obfuscation toolkit only provides DES and DES3, we could reasonably assume that we can decrypt the credit cards. So even wrapped PLSQL source code is not secure. And this example, even though it's got no body, was taken from a real system in the UK that's used to encrypt about 20,000 credit cards that I was able to decrypt in about 2 minutes. It's also possible to plant Trojans in wrapped files without actually unwrapping them. I showed this about 5 years ago in a paper that I wrote, exploiting and protecting Oracle, where I found a string, I think it was something like alter session set NLS language, and I changed it to alter user sys identified by something else. And if you change that in a key file that was likely to be rerun by the DBA, for instance, something that gets picked up by catalog.sql or catprop, then there's a chance that you can leave it there and the DBA will run it for you. Change the sys password and you can get in later. SQL injection is probably possible, or whether you can actually describe it as SQL injection is another thing by doing the same technique. Oh yeah, and I mentioned here another issue I had when I was writing a program probably about 3 years ago. I was using DBMS output, and if everyone has used that before, usually it throws an error if you try and output more than 1 million bytes. And because it's wrapped, I reasoned that I could work out the algorithm, and I had Oracle 7.2 that was never shipped wrapped, so I could see the algorithm. And I found the variable that was actually setting the 1 million byte limit, and I edited it in the wrapped file, and I was able to then carry on using it. So it's possible to actually change the functionality of a wrapped PLSQL procedure, even without unwrapping it. So just looking inside the database as to what happens. Again, we've got PLSQL source code at the top. If you just loaded that into the database, then it'll compile it, and it stores the diameter and the M code in those 4 IDL tables that we saw earlier. And it also puts the source code in sys.source$, which is also exposed by DBA source and all source. Going the wrap route, the wrap creates the wrapped file, which is, as we know now, is Diana. Then the Diana is loaded back into the compiler, presumably, in the Oracle kernel, and loaded into the database in the same fashion as the back end of the compiler would if you just loaded it as clean source code. So just looking at these these tables. On the right-hand side, you've got the details of one of the IDL tables, IDL UB1$. The interesting part is the piece column, because that's where the actual data is stored. You can actually get the descriptions of these tables and how they're constructed from a file that's in the Oracle Home RDBMS admin directory, a file called sql.bsq that's run every time somebody creates a database. And if you look at the comments in there for these Diana tables, it actually tells you that a row with a value of 0 is Diana, and one with a part number of 1 is portable P code, and one with a part number of 2 is machine dependent P code. And again, at the bottom, we've just got the source dollar table where the actual source code is stored. Recursive SQL. Don't want to get into details about how Oracle database works, but it's relevant for what we're going to look at next. When you run a piece of SQL, for instance, I might type in execute procedure A as a user Scott. Oracle has to do a lot more work in the background before it can actually execute that. It has to go and get the source code for the procedure or the machine code, load it up ready to execute it, It's got to check the privileges, it's got to go and look at indexes, lots and lots of different things that it needs to do in the background. That's generally known as recursive SQL. So even though it's running as Scott, sys actually does a lot of work in the background first. It's possible to see what happens, which we'll look at next. So when compiling PLSQL, there are a lot of other background processes, SQL statements that need to run as sys. So these could be privileges, triggers, for instance, retrieving the PLSQL source code or indexes. So how can you see the complete picture? Well, it's possible because Oracle provided a wait interface. So they've instrumented the Oracle kernel and allowed you to trace how the Oracle kernel works. And you can set trace, different level of trace. You can set some special events that do different things. The general trace event is 10046, and you can set that to run at different levels. You can either just get the simple trace, or you can get the bind variables on the wait events as well. It's also possible to dump data from the shared memory segments and also from data files in the database with dump commands, which we'll look at later as well. So assuming we wanted to trace the compilation of our simple procedure, then we just use an alter session command and set the 10046 event, which is actually just trace. And we tell it to be level 12, which says we want to see the bind variables and the wait events as well. And then we create the procedure, and then we have to turn the trace back off again. And that gives us a trace file, which I should have here. Not that one. I think that's this one. Okay. So the bit on the slide is just pulled from this trace file, but it's easier to see it in the context of the trace file. So the actual database is doing a lot of work. It's doing select count star from IDL UB2$. It's deleted the contents of IDL UB2$, and then it's doing an update. So it's actually putting, because we're doing a compile, it's actually loading the Diana into the IDL UB2$ table. And you see these values here. These look familiar, 1D, 17, 9A, 68. These are the same values that we could actually see in the wrapped file there. So you can see that that's the Diana, and it's putting it into the internal dictionary tables. Hence, those numbers look familiar. So one thing to look into to see the usefulness of this is that what we needed to do was check these IDL tables to see if these tables always store Diana, because we now know that Diana is wrapped PLSQL source code. Is the Diana stored for every piece of PLSQL in the database? Unfortunately, it's not. This piece of SQL is just doing a union on the 4 tables, and it's just, it's just selecting a count, and it's I'm trying to find the cursor so I can point at it. It's just highlighting which table it's coming from. Highlighting the table it's coming from, looking at the part, the object type, and so on. And we're looking for part 0 because that's Diana. And we're just seeing which types of objects have Diana stored in the database. So that's operators, procedures, type bodies, functions, packages, which is the actual package header, not the package body. So for package bodies, the Diana is not stored in the database, but the M code is. So if you wanted to unwrap PLSQL, it's probably not going to be feasible to unwrap all PLSQL from the database because it's not actually stored. Oracle throws it away after it's compiled it doesn't keep it. So we want to look at the IDL that was actually created for our simple procedure AA. These SQL scripts are available on the CD because they're quite long to type in by hand. Sorry.
So you're saying that the database doesn't store Diana for all packages and procedures and store M code?
It stores the M code for all PLSQL, as far as I'm aware, but it only stores Diana for some types of PLSQL.
And then if you do restore the database onto a different architecture platform, what's going to happen then?
They get installed because it's platform independent. It's running in a virtual machine. So the environment is just an interpreter. So it's a PLSQL interpreter.
The M code is not platform specific?
No, no. So we wanted to actually see what Diana was created for our simple procedure. So I've created another big lump of SQL here that looks at the 4 tables, and we're actually pulling out the row IDs because we want to be able to dump the contents from the data files, which will become apparent why in a minute. So I've actually pulled out the actual blocks, because Oracle stores data in blocks on the file system. And the size of those blocks are configurable, and there are lots of different types of blocks. What I've done is listed out the file number and the row number and the block number, which will become useful in a minute. And the actual table it's come from, and I've highlighted the UB2 one, because we've already been looking at UB2, and that's where the Diana nodes are stored. Part number is 0, which is Diana, and piece number is just there are, in this case, 5 different pieces of Diana, and 3 pieces of M code, which are the parts 0 and part 2. And the length is 123 bytes. So on this slide here, what I was trying to do was select the actual Diana from the IDL UB2 table. I found the object identifier for obj$ for where my procedure is called AA, and I try and select out the Diana for piece 4, which is what we highlighted in the last slide. But you can't do that, it fails. Or a 932 inconsistent data types, because the actual data type used in the IDL dollar tables for the piece column are actually undefined. They're not implemented through the normal SQL interface. I guess it's possible to actually select from them somewhere, because Oracle is actually doing it internally. So if you look at the statements that are generated in the trace that we looked at a few slides ago, Oracle's actually doing selects on those tables, including the piece column. So clearly it's possible to do it, but at a lower level in the Oracle kernel. But we can't just do it in SQL+. So the way to get the actual data is to use a dump command, which allows us to dump data file 1, which in this case is the system table space. And we want to get that block number, which is the one that we actually identified with the SQL in the previous slide. So that does a dump, and that actually dumps it to a trace file. You can then scroll through the trace file, and because I wanted row 8, you can see here it's row 8 at the top. So I've actually scrolled through and found row 8 for that table. And again, as you'll see, the highlighted, the bolded values, 17.1d, 68.9a, are obviously familiar. They are the Diana. Okay, a little detour. So what does Oracle use IDL tables for? It's always interesting to spread your search a little bit. There's quite an interesting view called DBA dependencies that you can use in 2 directions. You can see for a particular object which other object it relies on, or you can go back up the chain and do it the other way. So you can see, for instance, for a particular table, which other objects use it. And I've just done that for the IDL tables, and you find that all of these objects actually use the IDL tables for something. Some of them are views for actually looking at, like for instance, parse pieces is the actual looking at the size of the PLSQL that's in the database. So people who are interested in tuning and sizing would look at this. But it's quite interesting that, for instance, in init JVM orgs uses it, which is the Java virtual machine. And probe at the top is the PLSQL debugger. That's the old name for DBMS debug. It used to be called probe. So just looking at one of those as an example, code pieces. Just describing the view doesn't tell us anything, but we can select the text for that view from DBA views, and the text is on the right hand side, so it's just doing a union of the IDL tables, and presumably that's used for sizing to find out how much M code or P code or Diana is actually installed in the database and how big it is. The next is what we want to look at is the interfaces that Oracle have provided to the Diana and the IDL. They provide 2 packages, one called PIDL and one called Diana. I've actually just got these in TextPad, so a bit easier to see. The Diana package is called Diana. For a valid Diana implementation, any implementer, this is particularly aimed at Ada, but I guess it applies to PLSQL as well, is that they need to provide a package like this that provides certain operations that are available to act on the abstract data type. The interesting part that we'll just look at here is the actual names of the Diana nodes. So we can see things like dabort is the name of a Diana node, For instance, d_comp_u is the name of a Diana node. We'll come back to them in a minute. The PIDL package is package portable IDL. There is lots of definitions of data types and sizes that are used throughout the PIDL package and also the DI utility package that we'll look at in a minute. And there's some interesting functions, these that are on the screen now. PTF_kin tells you the type of a node. So if you actually know the value of a node, for instance 9A that we saw previously, you can actually get the type of that node. So you can see if it's d_comp_u, for instance. So I pointed the wrong one, it's that one. Then there's some interesting functions here that tells you the number of attributes that a particular node's got. It'll tell you the text name of the node. It'll tell you the text name of the attributes as well. So that's quite interesting. We'll see them again in a minute as well. So both of those files are available in the Oracle Home RDBMS admin directory as pidl.sql and pidian.sql. And they provide an API to Diana, which, as we now know that PLSQL, wrapped PLSQL is Diana, it's providing an API to the wrapped PLSQL as well. There's another interesting file called diutil that's got some functions in it, which I think I might have open in TextPad as well. No, I haven't. Let me just open it. Diutility provides a function called pstub that was provided by Oracle. We'll come back to this in a minute, but I'll just show you this package. It provides a function called pstub that's in its a separate file, but it's actually then calls the pstub in diutility. And if you scroll through this file, you can see that it's actually using Diana stuff as well, because you can see in there's the Diana functions. For instance, there, Diana.AUnitB to get the attribute that's pointed at from a particular node for the AUnitB attribute. So that's diutil. Again, it's in the same directory. Oracle also provided another useful script called dumpDiana, which does as it says on the tin. Again, that's in the Oracle Home RDBMS admin directory. It's not installed by default. You have to run the script as sys or as internal with an earlier version of Oracle. If you try and install it, you'll find that it fails. You have to fix 2 bugs in it to make it work. There's actually 2 lines with rem and then a lot of dash symbols. If you actually remove those, it installs and compiles properly. You need to check that the Diana PIDL, and the diutility packages are there as well. Then you can run dumpDiana, which is what's shown at the bottom of the screen, and just pass in the name of our simple procedure, and it creates a trace file, which I'll just show you a clean one because it's a bit easier to see. So it creates this trace file, and you can see that the names of the Diana nodes are the ones beginning with D, for instance d_comp_u, or ds_body, or di_proc for procedure, d_p. The values that are below those are the attributes that we talked about previously, and they are some of those are pointers to other nodes, so that creates the tree structure. Some of them are lexical attributes. So for instance, lsimrep is a lexical attribute which stores the name of the procedure. Every node has an L source position, which shows the source position, row and column, in the original PLSQL source code. All of the ones beginning with A are structural attributes, so they are pointers to other nodes in the tree. The ones beginning with S are semantic attributes, which are populated during the static semantic phase of the compiler. And the ones beginning with C are code attributes, which have got something to do with the code generation. And that's what the slide shows there, although it's a little harder to see when you try and fit it on a slide. Interestingly, this book also shows the same information on page 137 and 144 to 144. This is known as the external representation of Diana. This book states that for Diana to be a valid producer or consumer of Diana, it has to be able to create or read Diana in this format. So attributed structure tree. So there's an example here of the block part of that same trace file. So you can see the D block, DS item, DS statement, and DS alter. They're the three sections of the main body of the procedure. The DS item is local variables, the DS statement is the actual statements in the middle, and the DS alter is the exception clause. We'll see this in a second. The PD syntax is also shown in this same book, exactly the same on page 151. So obviously Oracle has implemented the Diana packages and internal stuff the same as from an Ada compiler. Each node type has a variable number of attributes. We'll look at that again in a minute. Some of those attributes are pointers to other nodes, and some of the things like source position is mandatory. It's on every node. Ada also had another mandatory lexical attribute called LX comment, which is not in PLSQL. So reconstructing PLSQL source code from Diana. Just looking at the block syntax for PLSQL, this is taken from Ada, but it's basically the same. So the top bit there is actually from the Bacchus-Noor form of the compiler. So showing what the block statement constructed of. So it can have a simple name in Ada. Has a declare keyword. The declarative part is where you put the local variables. A begin statement, that's where you put your statements, like if something, else something, or whatever else. And an exception keyword, where the exception handler will go. And then an end keyword. Looking at the Diana rules, these are all taken from this Diana book, which is for Ada, but essentially it's the same for PLSQL. The block is made up of three sections: an AS item, an AS statement, and an AS alter, which we saw in the previous slide. Oops. So you can say the AS item, AS statement, AS alter. So that's exactly the same as it was in Ada, because this information on this slide is taken straight from this book. There's an alternative Diana dump that you can do with the dump Diana command. You can actually tell it to dump it in line format instead of as a tree format. I actually find it's easier to read it in line format. So again, for the same body, you can see, for the same procedure, you can see the body. So AD is pointing at the actual body of the procedure. A header points at the parameters and the block and so on. And A up is in quite a lot of them, which is a backwards pointer. Interestingly, in here, Ada doesn't provide a backwards pointer as part of its standard. So going back to reconstructing the source code, clearly we can see to reconstruct that source code, we'd need to generate the keyword declare. We'd need to get whatever's in the item Diana node. We'd have to generate the begin keyword, then do the same with statement, and the same with the exception clause. So you can see there's a very close correspondence between the Diana and the original PLSQL source code. So those numbers that we saw earlier on, 9A, B4, etc. If we convert those hexadecimal values, or we can read them from the trace file as well in here. So if we took DS body, for instance, we can go to the Diana package and find DS body. If I spell it right. Oops. Let's take a different one, diproc. So we find diproc in there, and that's got a value of 154. So for diproc, that maps to 9A, which is what we saw in the wrapped file as well. AB, so 9A there, that's the Diana node for the procedure. So what I've done is, for those same, if you went through the trace file, which is what I did, this trace file here, and picked out all the node names, and then mapped those to the decimal values from the Diana package, and then convert them to hexadecimal with a hexadecimal converter, you end up converting back to the same list of nodes that we saw originally. So it confirms that the wrapped format is Diana. So how would we actually reconstruct PLSQL source code from Diana? I've just drawn this little diagram to show that the structure of the Diana nodes by looking at the nodes we saw there, and we just get this directly from the trace file from dump Diana. So it starts with decomp unit, which is the compilation unit, I guess. That has an attribute of body, which has an attribute of procedure, and also one d underscore p underscore, which is the parameters, and also one for the main block, which has then got 3 further attributes for the local variables, the actual statements, and the exception clause. So using that information, we should be able to reconstruct the PLSQL. This pstub procedure that I talked about earlier, this essentially does the same thing. This procedure was shipped when Oracle clients were running PLSQL version 1 and they needed to call higher versions of PLSQL on the server. It was necessary to create a wrapper procedure that could be sent to the server to be executed. And if you actually look at the source code of pstub, because it's not wrapped, you can see that they're actually getting the information to generate this wrapper by using the Diana, not by reading PLSQL source code. So Oracle have actually shipped a PLSQL unwrapper for years with the database. So what we need to do is use the lessons learned from that to do the same thing. There's also another procedure in the same package called subptxt, which is basically doing a describe. So it does a describe of the procedure, same as running the describe command. And again, that uses Diana to get its information. So they're not really demonstration programs, they had a proper purpose, which was to allow version 2 PLSQL to be executed on the server from a version 1 PLSQL virtual machine on the client, which is what it says there. So both read the Diana, not the PLSQL source code. I guess that's because it had to work with wrapped source code and unwrapped source code. The extpr text function, which is in the DI utility package, is an excellent example of how to use Diana and PIDL package calls to actually read the Diana. So if you study that, you can see how to write an unwrapper. So, writing an unwrapper. To be able to write an unwrapper, you need to understand the relationship between Diana and PLSQL language keywords. So you need to know which keyword in PLSQL, for instance, procedure, maps to which node in Diana, which is what we just seen, the DI prop node. You need a way to parse the Diana, so you need to get at the Diana. The Diana is either stored in a wrapped file, it's stored in the IDL dollar tables. I guess it's stored in memory as well while it's being executed. One way to do that is to get it from the IDL tables and use the API calls, which are in the Diana packages and in the PIDL package. So you need a way to read and understand the Diana node types. You can get that from the Diana package and also the PIDL. You can actually read a node number like we showed manually, and you can actually see that 9A is the procedure DI proc, and then you can manually convert that back to a procedure keyword. So mapping PLSQL to Diana for some language constructs can be done using test programs and analyzing the Diana. So you can actually use the procedures that Oracle give you, the API calls. So the limitations of a PLSQL-based, API-based unwrapper. There are a number of limitations. The first 2 lines just saying how it can be done. The DI-util gives an example. There's some problems with using the PIDL package because the Diana isn't stored in the IDL tables for all PLSQL. It's only stored for procedures and functions and a few other bits and bobs. But also, even for procedures, it only allows you to access the parameters and the bits necessary to generate the wrappers that we showed in the pstub example. For instance, we're showing in the next slide that if you put some PLSQL statements in the body of a procedure and use the API calls to then walk the Diana, it doesn't actually get them back, and dump Diana doesn't show them either, so it's quite limited. It should be possible to write a complete unwrapper in PLSQL using the same functions, but reading the Diana from sys.source$ instead. So just an example of the limitation. So we've created a procedure here, AH, that's got a body in it this time with an if statement, an else statement. If you look at the dump Diana, you'll see that it actually doesn't generate the Diana using the dump Diana package, so it's not visible. So clearly that's not a way to write an unwrapper. Quite interestingly, this script is available on the CD called attrib.sql. I'll just open that up, which I haven't got already. This is just a simple procedure that's using the PIDL package functions that we showed earlier that allow you to get the text name of a Diana node and allow you to find the number of node attributes that each node has, and also to get the text names of those nodes, the data types, and so on. So if you run that procedure for a 23, which is dcompute, you can see that it's got 9 attributes. These numbers here, 9, 40, 62, they're just individual identifiers. And the text names, these are the actual attribute names, and the data types. For instance, 1, you can go back to the PIDL package and you can see that 1 is a type of PT node, which is a node, a Diana node. So you can see that's one of the structure attributes that points to another Diana node. So can you create a complete real unwrapper? Obviously you can, because there are ones out there that people are using, and some guys actually selling to people as well. To actually create a complete unwrapper, you need the complete PLSQL grammar. You can either get that, there's the AMTLR of the PLSQL grammar, I'm not sure how complete it is. And also the PLSQL user reference guide includes the grammar for most of the PLSQL constructs as well. To create a complete unwrapper, it would be necessary to understand all the Diana nodes that are generated for every keyword or PLSQL construct, which would be quite difficult. That's not documented. Partly it's documented for Ada in here, in chapter 2. So the sort of core language features, it's possible to find out what Diana nodes are generated from the Ada point of view, but whether they're actually the same nodes in PLSQL needs to be investigated. If you wanted to create a real unwrapper, then it's necessary to understand the wrap file format, because from what I've just said, you can't get it from the RDL dollar tables, because not all Diana is stored, and also for the ones that are stored when you use the API functions, it doesn't actually give you all the information. Quite interestingly, it may also be possible to disassemble the M code back to PLSQL. We'll look at that in a second as well. And the symbols are also embedded in the M code. If you actually look at the M code and show it in hex and use an ASCII converter, you can actually see the symbols within the M code in some cases. A useful view, $V reserved words, shows you all the SQL and PLSQL reserved words. There is an event that Oracle provides, 10928, that allows you to see the M code as assembler, so the machine code. So we've got a simple procedure here. We can set the event, run the procedure, then turn it back off again, and it gives us a trace file. And in there you can see the actual assembler instructions like enter or infer or ret. And these are actually split based around the line numbers of the PLSQL, so it's clear that line number information is stored in the M code as well. It's possible to natively compile PLSQL as well. There could be some issues around this, security issues. It should be possible, it's possible to natively compile all the PLSQL in the database. It should be possible to actually inject extra PLSQL code via the native compilation, or to inject C code as well, because it converts the PLSQL into C code and then compiles it. So it should be possible to actually inject C code into the process as well. So going back to, unwrapping PLSQL. I just wrote this little procedure called unwrap that's using some of the Diana packages just to familiarize with how they work. I started with the root node of the Diana and just found out the text names of the nodes and the attributes, and then walked the tree. This first procedure was just familiarizing with how it works. It shows it's a bit simpler, more simply how to actually use these APIs. So if you wanted to generate the code for that simple procedure that we had, you can see the DS body node has got a DI proc node with a lexical attribute of AA. DP is the parameters. There were no parameters for our simple procedure, so we've not implemented anything. The block itself contains the local variables, the actual statement, and the exception handler, but we've only got a null statement, so it's very, very simple. So to generate, what we've got on the left-hand side is the Diana. On the right-hand side is what we want to see in PLSQL. So we've got create. We have a space for inserting the procedure name. For the body, we want to generate the keyword is, begin. put something in for the body, the keyword exception if there is an exception handler, and then insert the actual exception handler clauses as well. And the actual statement itself should generate null and a semicolon. So proof of concept unwrapper is unwrap R, which I've got here somewhere. This is just a simple recursive descent parser. So what it's doing is using the same function that Oracle uses in the dump Diana package function to get the root node of the Diana, so the starting point for parsing the Diana. It then uses that and passes the root node into a function that I've created, a procedure I've created called recurse. And then the recurse procedure just implements an if clause for each different node type that I know is in that simple procedure that I've created. So decompilation unit, these are the same values that we can go back to. If I can find it, there. So those are the same values that we took from there. The Diana package provides functions with the same names as the node names, so it's quite comfortable for writing PLSQL based on it. So for each node, we're then looking at the various attributes where they're structural, so they point to other Diana nodes, so we're just basically walking the tree and calling the same function again. So it's just a recursive descent. And then particularly for the body, we've got is begin, we've got the null statement there where it's generating it. So it's just generating the various PLSQL keywords at the right places by reading the Diana. Let's go back forward to the same place. Okay, so just running it for the simple procedure AA generates the same PLSQL source code. But as I said before, this is quite limited because that's reading from the IDL tables, and that doesn't show the PLSQL, the Diana nodes, for anything more complicated than the null statement. If I'd had parameters, I could have generated the parameters again as well, which is what the pstub function does. But this is just a proof of concept to show that it is Diana and it's possible. And this is just a piece of the actual PLSQL that implements the one I just showed you there. These files are available on the CD. So 10G, what's the difference? There's a new wrapping mechanism in 10G. The most noticeable thing about this is that the symbol table is no longer visible. So on one level it's better because you can't read the symbol table anymore. But the encryption involves base 64, which fills you with dread if you think that that's an encryption algorithm. There's a posting on forums.oracle.com where somebody has stated that the encryption is based on compress and base 64. I think it's a little bit more complicated than that, but not much more. It's also possible in 10G release 2 to actually wrap PLSQL in the database itself. So there's a procedure added to the dbms DDL procedure that allows you to wrap PLSQL dynamically. So if you're generating PLSQL within your source code, it's now possible to wrap it while you're creating it. Yeah. It should be available to the public so that anyone who's creating PLSQL should be able to wrap their PLSQL. So anyone can do it. There's a new optimizing compiler for PLSQL as well in 10G. What's old is that the IDL tables are still there. They still contain Diana and M code for the same types of PLSQL. The same packages are still there, Diana, PIDL, DiUtility, dump Diana. And it's still possible to reverse simple procedures using the Diana APIs. But the main difference with 10G is that the source code is encrypted first and then decrypted when it's loaded. So we can look at a simple procedure that's been wrapped on 10G. And if you look at the actual, I was looking for my cursor. If you're looking at the actual wrapped part of the encrypted part of the PLSQL source code, you can see it's got the telltale equal signs on the end, which is base 64. If you unbase 64 it, there's nothing visible. But as I said, there's a posting on forums.oracle.com that states that it's a combination of compress and base 64 and something else. So just using the same example that we did on 9i, we just create the same procedure We wrap it, then we load it into the database, the wrapped procedure, and we can run the row ID SQL again. We can see that it generates almost the same IDL as on 9i. So if you look for the UB$2 column, it's now 131 bytes in length rather than 123, but essentially it's the same. You can run dump Diana, exactly the same. And you can also run the Unwrap R script that I just demonstrated, and again it'll unwrap it, but as I say, it's quite limited because it'll only unwrap quite simple procedures. So, can you protect PLSQL-based intellectual property? Writing PLSQL as packages has got to be better in 9i because the Diana's not stored in the database, but the Diana is stored in the database in the sys.user$ table. The 9i and 10G wrap mechanisms have both been cracked and unwrappers are available, but not to most people. So wrapping is still useful because most people don't have unwrappers. And even the unwrappers that do exist are not that good either. There's one that has been sold to various security companies. It actually only unwraps a quite small percentage of the Diana nodes. So it's not as good as it seems on first looking at it. Don't ship the source code to the server, so don't put your source code files on the server even if they're wrapped. And obviously protect the various dictionary tables such as source dollar, the IDL tables, to prevent anyone from reading those tables in the database to be able to get at the Diana. But actually creating an unwrapper against Diana is not trivial anyway, so it's not likely that most people are going to be able to create one anyway. I think the 10G protection is better on one level because it protects the symbol table, but on another level it's not as strong because the 9i mechanism is clearly much more complicated than a simple encryption used in 10G. It's interesting that Oracle ship the source code, the packages for OEM using the 9i wrapper even for 10G. I don't know if that's just a mistake within Oracle or it's intentional. As we said, protect the various database tables. There's some scripts on my website on the tools page that you can use to actually see which users or roles can access the various tables. For instance, there's a script called who can access. You just pass it the name of a table and it'll tell you hierarchically, even if someone's got a privilege via a role, whether they can access a particular table or view. And the scripts that I've used in the talk are listed there. They're on the CD, and they're also available from my website as well. And any questions? No. On source dollar, there isn't a default select on it. All source, any user who can see the source code for any procedure that they've created or one where they've been granted access to. There isn't a default select on DBA source. There is via certain roles. If you've been given certain built-in roles, then there's a default select on it. Things like select catalog role. So I missed the beginning of that. There's some views that allow you that access the IDL tables, but they don't access the piece column. They're only doing summations on the size, so they're not useful for anyone to read the Diana. And as I say, the main thing is that the actual Diana that's visible from those tables is not really useful to write a proper unwrapper anyway. Anybody else? No? Okay, thank you very much.